In this video, we solve problems for section 1.1 and we'll give you the idea how to solve every problem. So we try to select some of the problem and we show the solution to each problem. So the problem 62 say like this. Suppose that the total cost in dollar of manufacturing Q units of a certain commodity is given by this function. What it means this? The Q is the X. To manufacture, the Q is the X. Manufacture one unit or 2 units have a cost. For this model of cost, the model vary like Q cube. When Q is 0, when you don't produce anything, the cost will be 500. So the function will start here. As the Q progress, as Q is 1, 2, 3, 4, the function will do something like this because it's a cubic function. It may do a negative cost, it may do a negative cost, but I don't think that it will do. It will go up, the cost will go up. So what it say, I don't know, it may go, you can plot in GeoGebra this function, maybe do like this, with this because it's a cubic function, a cubic function will do like this, maybe it's coming like this and do it like this, and it has 3 roots. Maybe it is this kind of function, maybe not. As I say, you go to GeoGebra and you graph this function. So let's go to answer what it say. What is the cost of manufacturing 20 units? Well, this is the cost of manufacturing Q equal 20. What will be this cost? It will be Q cube. Q cube will be 20 cube minus 30 times Q squared, 20 squared, plus 400 times Q 20, plus 500. And this cost is in dollar. So you spend this amount of money to produce 20 units. Maybe is the car industry. So Q equal 20 means that you produce 20 cars. So to produce 20 cars, the cost will be 20 cube minus 30 times 20 squared plus 420 plus 500. The second question say, compute the cost of manufacturing the 20th unit. So the 20 units is not C of 20. C of 20, if you make your calculator, it will give you an amount of dollar. I don't know, very easy to take your calculator and do it, whatever. But what is asking the question B, this is question A, what is asking the question B is, how much is the cost to produce the 20 units? Not all the units cost the same. As you progress doing more units, the cost will change. The total cost of producing the 20 units is this one, but what is the cost of producing the last unit? The cost of producing the last unit is the cost of producing 20 units minus the cost of producing 19 units. So this is the cost of producing the 20 units. So you do this algebra, is C of 20 is known, and now you subtract 20 cubed minus 30 times 20 squared plus 400 by 20 plus 500 minus, now minus what? Minus C of 19, the cost of producing 19 cars. So the cost of producing 19 cars and the cost of producing 20 cars, the difference between the cost of producing 20 cars minus the cost of producing 19 cars should be the cost of producing the 20th card. So this is the cost of producing 19 cards. This is the cost of producing 20 cards. And the difference is the cost of producing the last card, the 20 card. So I have to subtract here 19 cubed minus 30 times 19 squared plus 400 multiplied by 19 plus 500. So this is C of 19, and this is everything here is C of 20. The subtraction will tell you how much costs in dollar the 20th car. Let's go to the next problem. Let's say here a ball has been dropped from the top of the building. So imagine this is the building, this is the floor. Its height after t seconds is given by a function that is h of t. Let's go because this is the y-axis. The h of t is the y, so we can write like this: y of t equal minus 16 times t squared plus 256. So at t equals 0, what happened? What is y of 0? Y at t equals 0 is minus 16t squared plus 256. So at t equals 0, at the starting time, the ball is at plus 256. So the height of the building is 256 meters. What it say? What is the height of the ball after 2 seconds? It say, so this measure, the y is measuring from the floor. It's 256 from the floor. So what is y of 2? After 2 seconds, the position of the ball has changed. What is y of 2? Easy, replace t by 2 and will be minus 16, 2 squared plus 256. And because here appears 16, it should be in feet. This is feet per second square. So it's 256 feet. Should be feet. This unit should be feet. So what is the height after 2 seconds? Here, 16 minus 16 by 4 minus 16 multiplied by 4 plus 256. This is a positive quantity because 16 by 4 is 64 minus 64 plus 256 is around, let's say, 190. So the ball will be around here. Around this point will be the ball. Okay, at 190 feet. So the question A is already answered. You make the right calculation. Okay. The question B say, how far will travel the ball during the 3rd second? How far will travel the ball during the 3rd second? So how far means y of 3? How far from the top? From the top. So I would say, what is y of 3? Y of 3 is the position after 3 seconds. Maybe here. Maybe it's here, in here. So how far has traveled? Has traveled from here to here. From the top to from the top to the position. So y of 3 is 16 multiplied by 3 squared minus 16 multiplied by 3 squared plus 256, and this will be 9 by 16 will be minus 54, 9, 144, I think, 9 by 16, 144 plus 256. This is around 112. Let me see, 112 is 16, yes, 112. Okay, 112 fifth is somewhere like in the somewhere like this through here maybe. And how far has traveled? He has traveled 256 meters minus 112. He has traveled everything minus this. He has traveled this amount of feet. How tall is the building? Well, we said at the beginning the building is 256. When will the ball hit the ground? Well, hit the ground when y of t is 0. When y of t is 0, so the c is already answered, is 256 feet. And you see, a ball has been drawn. You see, this problem, they should say feet. They should say, but they don't say. Okay, how tall is the building? Is 256, because at t equals 0, the y is 256. When will the ball hit the ball? So y of t, d, when y of t is minus 16t squared plus 256. So when y0, it hits the floor. But at what time? Well, we can find the time by solving this equation. So the time t will be 16t squared will be 256. So t squared will be 256 divided by 16. So t equal plus minus, but we will choose the positive sign because it's the time after you launch, not before you launch. And 256 divided by 16. This is how much it will be without using the calculator. This will be 256 divided by 10 is like 25. It will be like 4 seconds, I think. T equal like 4 seconds more or less. After 4 seconds, the ball, well, after this time, the ball will reach the floor. So this is a problem about a function. The function is h of t or y of t equal minus 16t squared, and you have learned how to extract information from the function. We have extract a lot of information from the function. Let's go to another problem. Now population 67, population growth. It is estimated that 10 years from now the population is growing up or maybe decreasing. Like 20, the graph of this function p of t, you can graph it in GeoGebra, for example, but we don't need to graph this function. We need to answer this question. The first question say if this is the population after time t, so it means when the time is one what? Year, t years, 1 year. After 1 year, the population is 20 minus 6 divided by 1 plus 1. 6 divided plus 1 plus 1 is 6 divided by 2. 6 divided by 2 is 3. 20 minus 3 is 70. So P of 1, the population after 1 year is 70. And what is the initial population at time t equals 0? At time t equals 0, the initial population is, if you plug in 0 here, so it will be 6 divided by 1 is 6. 20 minus 6 is 14. So the population grow up from t equals 0 to t equals 1. Okay, what will be the population of the community after 9 years? from now. So it's asking you what is P of 9. P at the time t equal 9 years is 20 minus 6 divided by 9 plus 1. 6 divided by 9 is 20 minus 6 divided by 10, or 20 minus 0.6, or 19.40. 19.40 thousands. Population is measured in thousands of people. Okay, so we have answered the question A. Question B say, by how much will the population increase during the 9 years? During the 9 years, you need to find B, what is P of 9 minus P of 8. This is the increasing of the population in the 9 years. You know what is P of 9 is 19.8, 19.4 minus P of 8, but P of 8 is again 20 minus 6 divided by 8 plus 1, and 8 plus 1 is 9, so it will be 19.4 minus, open parentheses, 20 minus 69 is the same as 69 is the same 69. If I divide by 3 the numerator and I divide by 3 the denominator, 6 divided by 3 is 2, 9 divided by 3 is 3, so this is 2/3. Now this, you do the calculation, and now the amount of the increasing of from the population from P8 to P9, the population increase in a factor that is this factor. How much it is this? Well, you have to do it. You have to make the calculation. Let's go to do it. 90.4 minus 60 divided by 3 minus 2/3. So this will be equal 19.4 minus 58 divided by 3. 58 divided by 3, 58 divided by 3, 60 divided by 3 is like 20, so this is less than 20, and I suppose that is less than 20, that 19.4, because in other case it will be a negative population, which means that people are dying, no? So let's go to calculate 19.4. Multiply by 3. Divide by 3 minus 58 divided by 3. So 20 by 3 is 60, but it's 19.4 is 1.2 less, so it's 60 is 58, 58.8 divided by 3 minus 58 divided by 3. So now is 0.8 divided by 3, or 8 divided by 30, or 4 divided by 15. Wow, this is the result. 4 divided by 15 if I didn't do any mistake. So the increasing in the population P of 9 minus P of 8 is 4 divided by 15,000 people. 1,000 people. Let's go to the part C. Let's go to read what it says. What happens to P of t as t gets larger and larger? So because P of t is the expression, is the function, the population as a function of time is 20 less 6 divided by t plus 1. When t goes to infinity, 6 divided by t plus 1 approach to 0, because you are dividing 6 between a big number. So if you divide $6 between millions of people, there is almost nothing for each one, so this is 0. So what is the population P when the times t approach to the infinity? When the time t approach to infinity, the population approach to 20,000 people. Interesting. Go to GeoGebra, please. Graph this function, p of t equal 20 minus 60 divided by t plus 1. It has an asymptote, but the asymptote is in t equal minus 1. So t equal minus 1 is 1 year before the function start to work. The function start to work at t equals 0, so no problem. So graph this function, and you will see that the function have an asymptote, horizontal asymptote that goes to the 20 to the vertical axis p of t, p as a function of t. So you plug in 20 here, and the function will do like this, and will approach to 20 all the time. Okay. Let's go to the next problem. And this problem is very similar as other problem that we have solved, so I leave you to solve it. If any doubt, please contact me. And on the next section, we will see a problem for section 1, 2, this one, and this one.